Good day guys! Today I'll be discussing about two topics in inorganic chemistry, stoichiometry and titration and chemical analysis. Stoichiometry is a term derived from the ancient Greek words stoichion, which means element, and metron, which means measure. So, stoichiometry, literally translated, means the measure of elements. It is defined as the study of quantitative measurements between the amounts of reactants used and the products formed in a chemical reaction. Because of the law of conservation of mass, which states that matter is neither created nor destroyed, we have to make sure that the amount of reactants should be equal to the amounts of products.
In a chemical equation, the elements present in the reaction are represented by their chemical symbols. The reactants are displayed on the left side and the products are on the right. The stoichiometric coefficient is the number written in front of atoms, ions, and molecules in a chemical reaction to balance the number of each element on both the reactant and product side. In this example, we are asked how many grams of sodium hydroxide are required to fully consume 3.1 grams of sulfuric acid. Here are the several steps to solve this problem. First, we have to balance the equation by adding coefficients. Using a mole ratio, we first need to know the quantity of sulfuric acid in moles. Now that we have the quantity of sulfuric acid in moles, let's convert from moles of sulfuric acid to moles of sodium hydroxide using the appropriate mole ratio. Now, we can have the mole of sodium hydroxide. Our last step is to convert the moles of sodium hydroxide to grams by using molar mass. We could have combined all three steps into a single calculation as shown in the following expression. Now, let's proceed to example number 2. We are asked how many carbon dioxide molecules are produced when 0.75 mole of propane is combusted according to this equation. As we can see, the given chemical equation is already balanced. Here, we are asked about the absolute number of molecules. To do that, we will be using Avogadro's number that is equal to 6.022 times 10 to the power of 23 molecules per mole.
We already have the knowledge about stoichiometry. Now, let me discuss about titration and chemical analysis. Titration is a common laboratory method of quantitative chemical analysis that is used to determine the unknown concentration of an identified analyte by reacting it with a solution with known concentration. Acid-base titrations are monitored by the changes of pH as titration progresses. The reaction is complete when it reaches the equivalence point wherein the amount of titrant added is just enough to completely neutralize the analyte solution. Often, an indicator is used to signal the end of the reaction, the endpoint. An endpoint refers to the point at which the indicator changes color in an acid-base titration. So, the addition of an indicator to the analyte solution helps us to visually spot the equivalence point.
Here is a sample problem. First, we balance the chemical equation. Then, we determine how much moles of sodium hydroxide. Using the molar ratio, we can calculate the moles of hydrochloric acid, divide the moles with its volume. This example is similar with previous example. However, instead of the concentration, we are asked to get the volume. To get the volume of barium hydroxide, we will use its concentration.
That's all for today. Thanks for watching.